Hello, young math Padawans. It's Mrs. Angel with your lesson for today on proving triangles are congruent with two shortcuts, side, 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 and side angle side. So here's what we know about congruent triangles. First, we know that all of the corresponding sides of congruent triangles are congruent. In the diagram above, we can tell which sides correspond based on the number of tick marks. AB is congruent to DE because each of those has one tick mark. BC is congruent to EF because they have two tick marks, and CA is congruent to FD because they have three tick marks. We also know that all of the corresponding angles of congruent triangles are also congruent. So angle A is congruent to angle D because they have one arc. Angle B and angle E are congruent because they have two arcs. And angle C and angle F are congruent because they have three arcs. So we can say without a doubt that because all of the corresponding sides of these triangles are congruent and all the corresponding angles are congruent, the two triangles themselves are congruent. So from here, we can write our triangle congruent statement. Taking all the corresponding angles from both triangles, we would say that triangle ABC is congruent to triangle DEF. But that's a lot of work to prove that all sides and all angles are congruent, so that's why geometry has theorems that are shortcuts, ways that you can prove two triangles are congruent with about half as much information. Our first shortcut is called side, 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 or SSS, and it states that if the three sides of one triangle are congruent to three sides of another triangle, that is enough information to conclude that the two triangles are congruent. So looking over here in this diagram, notice that we don't know anything about the angles. We're only given information about the sides. In both triangles, we have sides that have 1, 2, and 3 tick marks. So here's what we can conclude. According to this diagram, AB is congruent to DE, they have one tick mark. BC is congruent to EF, they have two tick marks. And CA is congruent to FD, they have three tick marks. So if you have two triangles where all three sides are congruent to each other, then we can conclude without a doubt the triangles are congruent, meaning they are the exact same size. So let's see if we can use side, side, side to determine if these two triangles over here are congruent. Now, every time we do this, we're always going to be given some information, either in the diagram or in writing. In our first example, we were given tick marks in the diagram. Now we're given information in writing. So let's see what we're given and what we can conclude. The first thing we're given is that side JL is congruent to side NM. So I'm going to take that information and add it to my diagram. I'm going to put one tick mark on side JL and one tick mark on side MN. And I'm also going to write that down over here in my conclusion so that I don't forget that important information. And that information was given to us. Now, just finding one pair of congruent sides does not mean these triangles are congruent. So let's see what else we are given. We're also given that point K is the midpoint of JN. Let's start with that, midpoint. That means the point directly in the middle of the segment, breaking it into two congruent parts. So K here is the midpoint of JN. We can conclude from that that the length of JK is equal to the length of NK. Those are congruent segments. So I'm going to add that over here to my conclusions. The JK is congruent to NK, and that's because we were given the midpoint information, right? If there's a midpoint, then it's going to make congruent segments. But that's only two sides, and we need three. So that's why we're given that K is also the midpoint of side LM. So from here, I can conclude that the length of LK is equal to the length of MK. So we have LK is congruent to MK. And again, how were we able to make that conclusion? Because we were given the information about a midpoint. So the big question is, have we shown enough to prove these triangles are congruent? Yeah, we have shown that all three sides from both triangles are congruent, Therefore, we can make the conclusion that the triangles are congruent. So I'm going to name the first triangle JLK. And congruent to triangle, what would have to be the name of the second triangle to show that it corresponds with JLK? Well, if we look at that, JLK goes from 1 tick to 3 ticks back to 2. So following that, if we went 1 tick to 3 ticks back to 2, we would name the second triangle NMK. And these are congruent by side, side, side congruence shortcut. Congruent shortcut number 2 is called side angle side, or SAS. And it states that if two sides and the included angle, again, that vocabulary is very important. Included angle means the angle included in those sides. So it literally goes side, angle, and then another side. So if the two sides and the included angle of one triangle is congruent to the two sides and the included angle of another triangle, then the two triangles are congruent. First thing I notice is that side AB and DE each have 1 tick mark, which means those sides are congruent. The next thing I notice is we have an angle that is included in these two sides. Angle B is congruent to angle E. Lastly, we have a second pair of sides, BC and EF, each with 2 tick marks, so we can say that those are congruent as well. So since we have a side, the included angle, and a side, congruent to the side, included angle, and a side, we can say that triangle ABC is congruent to triangle DEF. That's enough information to make that conclusion. Let's see if there's enough information here to determine if the triangles are congruent using side angle side. Again, instead of being given information in the diagram, we're given information in writing. The first piece of information we're given is that side AB is congruent to side CB. So I'm going to mark the diagram. AB is congruent to CB, and I'm going to include that in my conclusion so that I don't forget that information later. And that information was given to us. But that's not enough information to conclude that these triangles are congruent. So let's look at what else we're given. BD bisects angle ABC. What's a bisector again? Oh yeah, it just means that it's cutting the angle into two congruent parts. So if BD is bisecting angle ABC, that means that angle ABD is congruent to angle CBD. So I can come in here and add some arcs. ABD is congruent to CBD. And the reason we were able to make that conclusion is because we were talking about a bisector. We have a side and we have an angle, but to use side angle side, we need another side. Well, hold on. Don't both of these triangles have a side in common? BD is a side that both of these triangles share. So if you were to split up these two triangles and actually cut them apart, that length BD would be the same in both triangles. So since that's what we call a shared side, we can state that BD is congruent to itself because it is a shared side. So what did we just find out? We have a side, an included angle, and a side. So therefore, triangle ABD is congruent to triangle, what would have to be the name of the second triangle to show its corresponding parts to ABD? Well, since BD corresponds to itself, that would be CBD, by side angle side congruence. It's your turn to try. State whether these triangles can be proven congruent by side, 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 or side angle side. Let's see how you did. Everything we needed to know was given to us in the diagram. BC is congruent to DC, AC congruent to EC, And then we were able to conclude, because they're vertical angles, that angle ACB and ECD are congruent. Therefore, because we have a side, the included angle, and a side, congruent to the side, included angle, and a side, we can say the triangles are congruent by side, angle, side. Again, in the second one, everything we needed was given to us. We were able to show that AD is congruent to CB, DC and BA are congruent, and since AC is a shared side, we can say that it's congruent to itself. Therefore, triangle ADC is congruent to triangle CBA by side, side, side. That's it for today's lesson. I will see you next time.